morning, good afternoon, or good evening, wherever you are in the world. Unfortunately, this year we can't make it happen to have the Data Platform Summit 2020 in India on-prem. So this year is completely virtually, and I hope that you will enjoy it. So my session is about system version temporal tables, and you see behind me the party. Let's come on, we make party with system version temporal tables. Enjoy. Hi everybody, and welcome to my session about system version temporal tables. You have here the two download links. The first one is for the session and for the PowerPoint slides, what you will see in the next 60 minutes. And if you want to play around a little bit with my demos, then you need to download my demo database, which is present in the second link. You know, without sponsors, these kind of events won't happen, especially now when it is virtually. So a big thank you to all the sponsors of the Data Platform Summit in 2020, especially for Microsoft. My name is Uwe Ricken and I'm from Germany. I'm a Microsoft Certified Master, and when you have some questions about the topics I will handle here in this session, just drop me an email. So what will be our agenda today? Now, first of all, we need to have a cursory introduction to system version temporal table that you all will have the same level of knowledge about it. Afterwards, we go into the, let's say, pitfalls you might have when you're working with system version temporal tables. We'll talk about nullable attributes, which are constraints in a table, and we are talking about metadata operations, the nightmare of triggers, which is really a nightmare, can be a nightmare, and we want to see how the new security features, which are implemented since SQL Server 2016, will work with system version temporal tables. Calculated properties are quite often used in data warehouses or in partitioning architectures where you need to have a partition key which is calculated by two columns, for example. And the last point what I want to demonstrate to you is long-running transactions, which truly could be a nightmare, but let's see how it works. SQL Server has implemented temporal tables as a new feature in SQL Server 2016. Temporal tables will keep the full history of data changes and allow a dedicated point-in-time analysis. A temporal table contains a reference to another table with a mirrored schema, what means that we have always a table in our SQL Server database which has exactly the same metadata as my working table. Mostly, we will use this for calculation of trends in a predefined time period. Reconstruction of data in a dedicated table is also a great benefit of temporal tables. Forensic auditing is also a point. And last but not least, we have analysis of data in relational or historical data. How will temporal tables work? Well, basically, it's very easy. System versioning for a table will always be implemented as a pair of two tables. So what we need to have is two additional attributes with data type datetime2, which is used for the temporal validation of a record. If you're having a running application and you want to implement this temporal table feature afterwards, then don't worry. If you want to have it, but you don't want to have the columns visible in your table, just only mark them as hidden. The best practice for the architecture for a temporal table is a mandatory thing. You need to figure out what you want to do with your temporal table data, so with your historical data. So what we do when we implement temporal tables, we're dealing with a very simple strategy. First of all, what I do is I separate my history data from my running data. So as you can see here in this slide is I have a drive F, where is my file group and my working tables in a dedicated schema. You see here the customer, the invoices, all this kind of stuff. What we then do afterwards is that we have on another drive another file group with a dedicated schema. Just here, for example, I name it history, and then we put all our history table into this schema. So then we have a separation between the working tables and the history tables. If you have multiple disks available, then based on your workload, you can decide whether you want to have the data, the history data, on a fast drive, because you have a high transactional system, or if you just only want to store the data for any purposes which are not high transactional, then put it on a slower drive or a cheaper drive. If you decide to create a new table, just use the syntax you used before with one single dedicated point, which is here required. You say you want to have two dedicated attributes which are defined for the period for system time. If you have existing tables and you want to make them temporal tables, just only alter the table and add this period for system time statement to the table. I will show it later on in the demos. When you have created your temporal tables, you start inserting data into your table, and that means that you're using DML operations. Please note that only update, delete, and merge statements will affect the temporal tables. So when you insert a new row into your table, nothing has changed. So why should we put a value or a row into the history table? So when you change a row, then the original row, the previous row, will automatically go into the history table, and then it's stored there. Same with the deletion of rows. If you run a delete command, then the row will automatically go into the history table. If you have an application, let's say a vendor application, and the application is running very well, don't worry about it. It will work the same way as before. So querying in the way as you know it, it will work the same. So run a select against a table, run it with a predicate, order by, all this kind of stuff will work as it was before. So when you want to access the history data, you're using a special syntax just only for the table where you want to have the history data from. So run a select statement from a table with a dedicated wording, say for system time. And then you define the period for this table from what you want to have the history data. Before you start with temporal tables, there are some requirements and some constraints you need to consider. So requirements are primary key constraint. The history table must have the same metadata, but it's okay so far, because when you store your data, or when SQL Server will store the data in the history table, it must have the same structure. Problem is that history table must not have constraints. So history tables are not allowed to have primary keys. They are not allowed to have foreign keys or any defaults, because history tables just only store data. They do nothing with that, nothing else with that. Some constraints we have when we are dealing with temporal tables. The truncate table is not allowed for temporal tables. Truncate table is not a data manipulation language operator. It is a DDL, data definition language operation, what means that we deallocate pages. So we do not remove row by row, but we deallocate all the pages where my rows are stored in. A direct manipulation of data in the history table is, for God's sake, it's not possible. It is protected by SQL Server. Update cascade is not allowed when a table is the detailed table of a foreign key relation. You cannot use instead of triggers in your regular tables when they are part of temporal table structures. File table, by the way, isn't allowed either, but I think that is clear because the data are not stored in the table, they are stored on the file system. When you want to create temporal tables, you have three different options to do that. The first option is that Microsoft SQL Server will create the history table for you, but Microsoft SQL Server will do it in an anonymous way. What means that the naming convention of SQL Server will happen here. I wouldn't recommend that because I want to have a clear understanding of my objects and where they belong to. The second option for you is that you predefine the name of the temporal table, of the history table, what SQL servers should use. If this object does not exist, then SQL Server will automatically create that for you. The third option for you is that you create your history table by yourself before you make it a temporal table. When then, it's the same as in the second option, when you then give the name of the of the object, then SQL Server will automatically check whether all the requirements are fulfilled, and then it makes it a history table to your temporal table. Keep in mind that the option 1 and 2 will by default create a clustered index on the history table which is compressed. Here you can see how you can create a temporal table. You start as you do it with your normal tables. You say create table and give it a name. Then you define all the columns you want to have in your table. Notice the two columns at the end. There's a start time and this end time. Both columns are marked for system versioning. So we say we generate it as row start and row end, which define the time period where this row is valid. The last point to make them system version, to make them controlled by system versioning is that you say the period for system time is defined by these two columns. If you then want to make it immediately with this one script a temporal table, just only add the last statement with system version is equal on, and optionally you can give a name for the history table. If it exists, then it will check. If not, then it gets created. So I have a demo for that. Come on, I show you how this will work. In my first demo, I want to show you how the requirements for temporal tables will be handled in SQL Server. Therefore, what we're doing is the following. I go into a previously prepared database, customer orders. So what I'm doing is I first of all create a file group called history. Within this file group, I then will create one dedicated database file. After the file has been created, we come now to the implementation of temporal tables. What I'm doing here is I create a new schema called history where our history data gets stored in. So I have a history addresses table, and before I implement it, let's have a look to the original table. So when I look into my databases, I go into the customer orders, and here in the tables, then you can see here that I have my addresses table. And have a look to the columns, what we have. And now compare the columns in the data table and compare it to the history table, and you will see that every single column in my history table will have the exact same data type and data size. So I want to refresh this, and now you can see we have our dbo.addresses, and here is my history addresses. So the table has been created. So the first thing is now that I want to try to make my dbo.addresses, so my original table, a system version temporal table. Problem here is that it will work because SQL Server will tell me, oh sorry, I cannot set system versioning on because we don't have the two columns which define the beginning and the end of the validation of my rows. So we need to have two additional columns which store the dates. So here is my definition. And that is really simple. What I'm telling SQL Server is please add to my table dbo.addresses a new column called start time and end time. Please note that I'm using the syntax for system version temporal tables generated always as row start. And what I'm doing here is I'm using a constraint. Last point is that I need to tell SQL Server, hey, come on, these both columns gets protected by SQL Server because these both columns define when a record is valid. And now I try it again. I run exactly the same command as before. So unfortunately, we get the next error message. Keep in mind that we have one more requirement. SQL Server requires a primary key on the table which you want to make a system version temporal table. So, well, that's missing. So what I'm doing is I now create on my dbo.addresses a primary clustered key. And I try it again, and unfortunately, I get again an error message. Setting system versioning is failed because the tables I want to use for it have different metadata. You can see here that the original addresses table has 8 columns, while the history table what I want to use only have 6 columns. And you keep in mind, when we created the address table, the history data first, we did it in the same way as the original dbo.addresses table, but now we have added 2 more columns to it. Put these 2 columns into it. So I'm creating 2 additional columns in the history.addresses. Well, there is one constraint because null is a constraint, but I do not add anything more. And here we are. I've implemented it. And now we have no more differences in it. Let me show all the columns from DBO addresses which are not in history addresses. And we don't have any. So now SQL Server has made my DBO addresses table a system versioned temporary table. And when we look into the tables, there is something what has changed. You remember that you saw the history.addresses at the very end here. It's not even more here. So what SQL Server did is it changed my DBO addresses table and made it system versioned. And now my history table is not a normal table in my SQL Server, but it is part of dbo.addresses. So you see now that the history addresses is now a part, and so this way under the dbo.addresses. Whenever you have system version tables implemented, you will see it by the naming, system versioned, and the history table will always be under the tree of the table itself. It will not be a normal table in the Object Explorer. So inserting data and running operations on your data, that's quite easy. But what will happen if you want to run queries against your data? So if you don't want to consider the history table, make your queries in the same way as before. So as long as you run your normal queries, you don't have to consider your history tables. So let's say you say run select star from customers where ID is equal 10. Then SQL Server will not consider the history table. This query will go directly into the temporary table. If you want to access history data, then you need to have a special syntax for it. Behind the name of the table, you only add for system time. And then SQL Server consider your history data in the same way as your normal table. I have a short demo for you, so just follow me around and I will show you how querying will work. So here is the third demo where I want to demonstrate how you can run queries against temporal tables. The table or the database is exactly the same, and what I'm doing is, while we were talking about temporal tables and I showed you a few demos, in the background I had lots of changes on a before prepared table called employees. And in the meantime, we have thousands of changes in it. And before we run the query, first of all, let me create the clustered index on the history table in the same way as Microsoft SQL Server is doing it. Microsoft SQL Server will create an index on the valid to and the valid from attribute. So I run this query and the index is now in. And before we go ahead and start with that, let me change how many changes do we have in the history table. And therefore I need a query where I run a count on the history table. I group it by the employee ID, and this is our result. And you can see here very fine that we, for example, have the number 43 where we have 15 changes so far. The last one was from 203, and please keep in mind, and that's really, really important, SQL Server stores validation dates only in UTC. So the answer to this is very simple. SQL Server have to make sure that we all are depending on one dedicated timestamp. And this is UTC so far. But you will see it in the query later on. So here is my first query. And with this query, I want to see all changes which have been made for the record with the ID 43. So therefore I use my table employees and I then say for system time all, so give me all the changes back. And here are my data, and here you have the valid from and the valid to fields. When you see here 2 o'clock afternoon, then it's because I changed the output to CST. So you see here that the last change was at 2:03, and this one is the valid record because the valid 2 is to the end of 9,999. Another thing what is really worth to mention is have a look to the chains here. You can see that the previous record, the valid from, is exactly the same timestamp as it is the valid from the latest one. And this goes here permanently exactly that way. So we have no broken chain here in the history of the data. The problem is the index. And why is it so? Let me show you the same query, but now I use the trace flag 9130 to make the pushdown predicate visible in the execution plan. So I run this query, exactly the same query again, and we get our 16 rows in between because the background process is running, and have a look to the execution plan. So in the execution plan, you can see that SQL Server is running a query against the dbo.employees, and then we go, because that's for the for system parameter here, you can see that SQL Server is now going on the history table here, history employees, and then look to the number of rows what it's running through. You can see here that we have 1,436 rows. That is the complete history table. And then we run into a filter where we run the predicate against the ID. And we come back with 16 rows. Come on, here we are, 16 or 15 rows. So think about that. If you have a table with lots of changes, it could definitely run into a problem, but I will show you how you can optimize this. Another kind of query is this one here. So what I want to do is I say, please give me for the employee number 43, the status of the record as it was 30 minutes before. So I run this query, and here we are, and we get just only one row back because at that single point of time we could only have one value or one status of the row. So when you go into this and have a look to the valid from, valid to, you can see here that we are now here 30 minutes back, or 15 or 20, what else? We say, what was the status 30 minutes before? And here's my criteria. You see 30 minutes running from this query is 145, and you can see that this value is in between these two timestamps. This is another point how you can run queries against the temporal tables. That gives you a good part that you can see, give me the status of my orders as they were 30 minutes before. So the problem is again the index. So what I'm doing now is I create the index dedicated to my queries, because you see that I'm focusing on the ID. You can change indexes from a history table whenever you want. This is not protected. So what I'm doing now is I'm changing my index. I want to have the ID first because I'm mostly running queries against the ID. And I run the query again. Give me the status 30 minutes before for the employee with the number 43. And here we go and look to this. Now we have a perfect index seek. You can see that the seek predicate is now on the ID and then on the valid to. So we get back with, say here, 8 rows. Then we filter it for the valid from must be lower than, and we come back with 1 row. This is way more efficient than the index from Microsoft. What can you do else? Well, let's say you want to have every change from a dedicated timestamp to the next. Therefore, you can use the system time from to. And let me show you what this will bring. So here I come back with 7 rows. And what I'm doing here is I show you the start date and the end date. This is my definition. So I said 20 minutes from 1:47 to 2:07. And all the rows which you will see here are based on this filter, but only on the valid from, because this one, you see it here very clear, is out of this range. But that is okay, because we want to have an information about all valid rows, all valid employees inside this timestamp. If you want to say, please give me only the rows which are from the beginning up to the end in this dedicated time zone or in time range, then you need to use contained. I run the same query again. Here I run this, go. And now I see that we have just only 2 rows. And have a look to the parameters. Here is my start date, which is coming from the variable. You see it's 13:48. And you see that they are all inside this time range, but on the other hand, you can see perfectly that the end date will not, or will always be higher than the valid to attribute coming from the table. So you can see that you have lots of possibilities to run queries against these temporal tables. So now you have seen how you can query history data, and here is a short summary of all the operators you can use. So now we come to the pitfalls of temporal tables. When you work with temporal tables, you need to take into consideration a few things which might not be so obviously. So what we want to handle in this first part is what will SQL Server do with nullable attributes? What means that we change them. The question comes up, for example, what will happen if null becomes not null in an empty table when the table is part of temporal tables? Follow me to the demo and I will show you what will happen. What I'm doing here is, in this demo, again, I go into my demo database, which you can download. And here I have created a store procedure just only for me, which prepares for me a demo customer table. So I gather all the data from my customers, from the properties, and then I create data. And here I create now an empty table called demo.customers. So I don't have filled it with data, it's empty. I want to show you what SQL Server is doing when we do metadata changes on the data table. So that when you want to see what SQL Server is logging, then you need to put it into a transaction. And inside the open transaction, there you can see what object SQL Server has blocked. I'm going ahead and say, please start my transaction. And here comes the first change in my table. You can expect that this will work because the data table is empty and the history table is empty. So when I want to change a column from nullable to not null, that should work. See what SQL Server is doing internally. Therefore, I'm looking into the transaction log or into the logs from the transaction. And what you can see here very fine is that SQL Server has put a schema modification log on both tables. Okay, we commit this transaction. So now we had made the changes. Here we are. And you can see that the phone number is not allowed to be empty. So here is my first record I insert into the table. And you see I have an email address and I have a phone number. So now we want to make another attribute not nullable, and it will work in the same way as it was with the phone number. Make a column from not nullable to nullable will work all the time. Now keep in mind that the email address can now allow nulls. I insert a new row, which is from Microsoft, but notice that I don't put in an email address. So when we look into the customers table, you can see here, this is Microsoft and the email address is empty. Now I want to make this column non-nullable, and to be honest, that won't work because then we would violate the constraint. So therefore, it's not working. What I'm doing is I'm now running an update on the email address for Microsoft. And now I want to try this. And now think what will happen. Basically, normally you would say, yeah, sure, it must work because now we fulfill all the requirements. We don't have any empty email address in it, but it won't. The reason now is that not the demo.customers is the problem, but the history.customers is the problem here. When we made changes to the Microsoft email address, the original value or the original row was moved into the history table. This is my history data, and the first one here, this is my actual row. And you can see it here from valid 2. So this one was the row which has been changed at 232, and from 232 up to the end of nowhere, this row is the valid one. What will happen if you delete existing columns? What will happen if we change the data types? And last but not least, I want to show you in a demo how renaming objects will work when your data are protected by temporal table architecture. So here is the demo. Come on, I will show it to you. Again, we go into our customer orders, and I now create my demo table. So the demo table is now filled, and if you have a look to my tables, you will see here is my demo customers, and I open it and want to show you just only the columns. You see here, I have my ID, my name, street, zip, city, phone, email. Before we run the demos, let me change a few rows, just only 1000, that's okay. And let's say we want to use fax numbers in our tables. We add this, and I run an update on it. We now have changed a few rows, and if I look to the data, so just only for one dedicated ID, one customer, and I want to see, do we have a fax number? It was previously null, and now it has been filled. You see, this is my old value. So now comes a very interesting point. We decide to add another attribute called mobile. This is not allowed to be null, so we have to fill it with data. If you have normal tables, you can force it to use it if you have a default. So in this case, I'm using the default not given. The question what comes up here is, what will SQL Server do when we have a system version temporal table? I run this query and it's running. We added a new column later than the rows have been inserted in the history table. I update the mobile numbers and now see how this looks like. Here again with the number 100, and you can see this. From the historical perspective, this record is invalid. At that time here, we never had any information about mobiles. The not given information will be used in a history table if a new column is used and you have a default value. So here is the third demo. I want to add a new attribute, pager, with a varchar 20, but not null. And I think you all know this cannot work. If you want to have a column which is not allowed to have null values in it, then you need to fill it. And this is what you never should do in a production system. Let's say we find out that we don't need the column email anymore. I can easily drop a column, so this will change our history data. If I run this query, first of all with email in, this is just only to show you that the column is not there, not in, but so now put it off. do not show the email and you see it's working. What does this mean for us? We have history data which are not correct. Some developers love to use triggers. If you have temporal tables implemented and you want to use triggers, then it can be a true nightmare. The point here is that triggers will create double entries in the history table, and the problem here is that instead of triggers are not allowed to use in the tables. Follow me, I will show you in a demo how this will work. Triggers can be a nightmare. Whenever you're using triggers, you need to be quite careful in the moment when you're using temporal tables. System version temporal tables do not allow instead of triggers. And that leads to a few problems with system versioning. Here you can see I go back in my customer orders database and I create again my table with around 87,000 rows. What you can see here now is I update it, refresh. We want to store the name of the guy who has changed this record. So what I'm doing therefore is I now add a new column to my table called update user. It is nullable. SQL Server now has updated it and we can go ahead. Here are my data. Now we decide to create a trigger. The only thing what my trigger here is doing is say if someone is running an update on the demo.customers, then fire this trigger which updates the customers table or write the update user with the original login names. So I implement this trigger. Here is my row with the number 10 and you can see here I don't have any changes. I ask here for system time all. I now update my row and now I'll check this first. I run the query and say, give me all the changes and you will see 2 rows. That's what you expect because we just only made one change and this one change is reflected in the query output. But the problem here is when you have a look to the execution plan. You see here is my customers, here's my history. Have a look to the estimated number of rows to be read. There is not just only one row, no, there are 2 rows. We just made one update. And the reason for that is, think about this, what happens when you run a trigger in a transaction. Here is the evidence that we have 2 rows in the history. This is my first and original one. And keep in mind the time track. What did we do? We did run an update on the name. This row, here we have changed it. And look to this, they belong together. So the first row is the original row. Then 2 minutes later, we changed and look to this, they are identical. Okay, we now know that the change or that the update of this one row, the result was 2 rows. The point is, when we run an update and we have a trigger, keep in mind that the trigger here is for update, which is the same as after update. Now think what SQL Server is doing. We were coming with the first update. I wanted to change the name. That was the first point. We are inside a transaction. So we know the beginning of the transaction. SQL Server knows the beginning and now the first row goes into the history table with the timestamp of the beginning of the transaction. So when this row was written into the history table, then the trigger jumps in and the trigger then fires again an update on the same row and write the original login name into the update user attribute. So this is the second update, and the second update requires that the first what we just made was going into the history table again. So this is something we don't want to have. You see it here, look to this, valid 2, it is exactly the same timestamp. There is a workaround for you. If you want to have this kind of implementation in your database and you're a fan of triggers and you want to have it and you want to have the system version temporal tables to use instead of triggers, first of all, you create a view. And that view is based on your table. And then I create a trigger. Have a look to this. This trigger here is not an after trigger. It is an instead of trigger. But this one is not referencing the table. This one is referencing my view. And then let's play around a little bit. Here is my number 11. That's a new row, and I want to see how many changes do we have for this row number 11. And you can see we don't have anything. I make an update on this one. I change the name to Microsoft. Now I run again the query and see what changes do we have. And from the regular query, I just only get one here. You see that we change from @repomex to the new one and the update user. But for us, it's interesting to see, did Microsoft SQL Server do 2 updates or did it run just only 1 update? We can see it in the execution plan. If I go here to the customers here in my history, the number of rows read 3. That is legal because the other 2 are from my former demo. And I can demonstrate it to you when I have a look to the history customers and see how many rows do we have for the record with the number 11. And you see it's just only 1. For you as a developer, it means that you have to create lots of views if you want to have this. And we go over to the next. With SQL Server 2016, lots of new features were coming into the game, especially security features. But to be honest, dynamic data masking, just for one example, it's not truly a security feature. It masks data, but it will not encrypt data. So these new security features, dynamic data masking and row-level security, can be used with temporal tables. Here comes my first demo, which shows you how dynamic data masking will work with temporal tables. In this first demo, I'm going to show you how the data masking is working. Again, I'm creating my demo customers table, which is filled with 80,000 rows. When we gonna have a look into the table, you will see that the phone number can be seen, it's not masked. So the requirement of the customer is that the phone number can only be seen by a special group of people. We now add a data masking function to the table and we put it on the column phone, which now should prevent seeing the phone numbers. Basically, we need to have the permission to see that. And for this demonstration, I create a new user without a login called a demo user. What I'm doing in the next step is that I grant the select, insert, update and delete permissions on the demo.customer, which is our system version temporal table. And on top of it, I grant the select permission on the history table that we can see what data we have in the customer table. When I now execute the next steps in the context of the demo user, you can see what's going on here. Here is my first query, and I want to see the data from the customer with the ID number 10. The demo user does not have the privilege to unmask the phone number. And you can see here that SQL Server is masking this phone number. What will happen if the demo user is updating a record? So here I update the customer with the number 10 in the context of the user, demo user. And we want to have a look to the actual and to the history data of the customer with the ID number 10. From my point of view, it is good implemented because the masking function is not just only for the demo table, demo customer table, but it is for the history customer table in the same way. Row-level security will give you a tiny feeling of security in your system. Row-level security will protect data based on a security function. That came new with SQL Server 2016, and the question came up here, how will SQL Server use this security feature in the history data? Follow me to the next demo and I will show you how this will work. With this demo, I want to show you how row-level security is interacting with system version temporal tables. In the first step, I'm creating my demo table. In the next step, I create 3 database roles. These database roles are for the alphabetic pre-selection of our customers. When I have created these roles, I create my user, demo user, and make him member of one of these database roles. In the last step, I assign the privileges to access the database tables, customers, and history table. The next step in the preparation phase is to add a new column to the demo.customers for the assigned database role. So every single customer who starts from A to H belongs to the role A to H, and so on. Here you see the result of all the changes. You can see that every single customer is belonging to a dedicated DB role. The first character of the company name controls to what role it belongs. Row-level security requires an inline table valued function with the condition you have to check whether you can see or edit a record. And in this case, I only check whether this actual user is member of the given database role or his member of the DB owner role. When the function is created, in the next step we need to apply this function as a security policy to our table. So now in the demo I start with the impersonation of my demo user and I want to see my data. Keep in mind that the demo user is member of the A to H role, and when I run a select on the table, I only see companies which are belonging to the roles where I'm member of. This is the way how row-level security is working. The question is what will happen with the history table when we have some data in it. In the next step, the user makes an update on the customer with the ID number 5. So it changes from the role A to H to the role I to P. Now the user wants to run a temporal query against the demo.customers table and wants to have all the changes for a customer with the ID number 5. You can see from the result that we only see the changed row which is in the history table, but we don't see the new one because Microsoft is belonging to a different database role, and that's the reason why we don't see it. But what will happen if we now make another update on the same customer? I make the customer with the ID number 5 now a new customer. You see that there is a different database role. And again, I'm executing as the demo user and wants to see all the changes for the customer with the ID number 5. And here you can see that we have a security breach here. If you want to prevent this, you have to apply the security policy from the demo.customers to the history table in the same way. After the implementation of the security policy, we again try to get all history data in the context of the demo user, and now you will see that we only get the rows which belongs to the role where this user belongs to. Have you ever been in the situation that you need calculated attributes in your table? People want to have it for different purposes. What will SQL Server do if you have calculated attributes in your temporal tables? Follow me to the next demo and I will show you how SQL Server will use calculated attributes in the history data. In this demo, I'm going to show you how calculated attributes will work with temporal tables. In the first step, I create my demo data, the demo.customers table. After the table has been created, you will see here that the demo.customers is now a temporal table, and we have our history customers as the history data. In the next step, I want to add a calculated column to it. In this example, I want to have the full address at the calculated based on the street, the city, and the zip code. I tried to add this column to my table, but it will fail because the demo customers table is part of system versioning. It cannot work. We first of all need to switch system versioning off. And now I try to add the calculated attribute again to the demo.customers table, and this time it will work. But we need to have this column in the history table in the same way. Add a calculated column to the history table. It works because system versioning is set off. So SQL Server will treat this table as a normal table, as you have lots of tables in your database. You will see the problem when you try to enable system versioning again. I now try to enable system versioning and you will see that it will fail. The reason is quite simple. What Microsoft SQL Server has detected that the history table has a computed column. This is in a history table of system version temporal tables not allowed. If you want to implement calculated attributes in your base table, then you have to go this way. I turn system versioning off. Now I add my calculated column to my base table. I now have to add a regular column to my history table. The size of the regular column in my history table depends on the calculated attribute. Let's do a little math here. You can see that I want to concatenate the street, the zip, and the city. So in total we have 208 bytes. The maximum size for the street is 100 bytes, but I want to add a comma and a blank afterwards. So that does mean that the maximum is 102 bytes. Plus a zip and a blank, which is 6 bytes. And last but not least, the city, which is 100 bytes. In total, we can store in the full address 208 bytes. I now add the regular column to the history table and try to set the system versioning on again. When I refresh the table list in my database, you will see that the demo.customers is system versioned again, and the history customers is the depending history table. In the column list, you will see that you have the full address here, and you have the same in the history table, but here it is a base column. In the next demo, we will see how SQL Server will work with this calculated attribute. I run an update on the record with the ID number 10. I change the name and the address to my personal address. And then I want to see the record and its depending history entries with the next query. Here is the original one, and SQL Server stores the full address with 208 bytes in the history table, while the full address in my regular table is only a calculated attribute and will not store it persistent here. We will come now to the last part of my session. I want to talk about long-running transactions and the problems you have with temporal tables. If you have long-running transactions in your OLTP database and these tables are using temporal table technology, it could be problematic if long-running transactions with heavy workloads are used. System version temporal tables use the transaction begin time as a reference for the history data. To explain the problematic situation, I want to draw your attention to the depiction here in this slide. The long-running transaction T1 is starting, and while this transaction is running, a second transaction is coming and makes an update on the demo.customers table. After transaction 2 commits, The transaction 1 will make an update on the demo.customers table 2 on the same record. This update will fail and the transaction will stop. The timestamp from the transaction 1 is earlier than the timestamp of the transaction 2. The last demo will show you how you can identify this problem, and I want to give you a possible solution to avoid this. For this demo, I have created 2 separate sessions. On the left side, there is my session where a long-running transaction is implemented. And while this transaction is running, I can switch over to the right side. And here we have a very short transaction, but both transactions will at least do the same. They want to update my customers table and the customer with the ID number 10. Before we start the transaction, I prepare my table, my demo.customers table. Now I start my transaction, and before we make the update or we start the long running process, we want to check at what time did this transaction start. You can see here that it was around 1:11 p.m. when this transaction was starting. And you see here this text, now comes the long running business process. While this transaction is open and the process is running, we go over into the second session, and here I start my transaction 2. I want to see when does this transaction start. And you will see here the difference between 1:11 and 10 seconds and 1:11 and 49 seconds. So the second transaction is 29 seconds or 39 seconds ahead. We run this update on the customers table, and then we commit our transaction. The record with the ID number 10 has been updated. I want to check the history data so far, and here is my old record, and you see that the timestamp of the validation, since what time is it valid, is exactly the start time of the transaction. Now the second transaction comes to the point where it will run the update on the customers table. You know that the transaction time was way before the second transaction. When now SQL Server tries to update the same record, it will fail. This error message tells you what is the problem. The transaction time was earlier than period start time for the affected row. The update could not happen, and you need to roll back your transaction. And when we look again from this transaction side to the rows, you will see exactly the same results.